Hello and welcome to section 14.2. This section deals with systems of equations. And so to start things off, let's look at the first question on the worksheet. It says consider the system, and here we're given two equations, y is equal to 3x minus 2 and y is equal to minus 5x plus 14. And so part A says describe the shape of each curve in the system. Okay, so there's these two equations. So I'll call this equation 1 and this equation 2. And these are both linear equations. Okay, so linear and linear. And we know the graph of a linear equation is just a line in the xy plane. And so for our answer to part A, we'll just say both graphs are lines in this case. Okay, now for part B, it says solve the system. Okay, now when it says to solve a system of equations, what we're asking here is to find the values of both x and y such that when we plug those values in, it'll make both equations true. Okay, so here's a way we could go about doing that. What I'm going to do in equation 1 is just note that, well, y is equal to 3x minus 2. And so then in equation 2, what I'm going to do is just replace y with this expression, 3x minus 2. Okay, so this is going to look like the following. So equation 2 is going to become 3x minus 2 on the left. And then on the right, we still have our minus 5x plus 14. And see, now I can go ahead and just solve this equation for x. Let's do that. I'll add 5x to both sides. And then I'll add 2 to both sides. All right, and so that gives us an 8x on the left and a 16 on the right. And so finally dividing both sides by 8, we find that x is equal to 2. Okay, so that is the x value. But again, when it says to solve, we need to find both x and y. Okay, so if I want to find y, knowing now that x is equal to 2, well, what I can do is just plug 2 in for x in either equation 1 or 2. It'll give me the same value either way. So let's go ahead and find y by plugging in x equals 2 into the first equation. So we'll get the following. Y is equal to 3 times x, which is 2 now. And then we're going to subtract 2 from that. And so this is 6 minus 2. So we get that y is equal to 4. All right. So two things here. First is that when I go to actually write the final answer, so for our final answer, I'm going to write this as an ordered pair. Okay, so x will come first. So x is 2, y comes second. So this is our final answer here. The other comments I want to make are, one, we could check our answer easily by just plugging in 2 for x and 4 for y and verify that these values make both equations 1 and 2 true. So let's just do a quick check there. So if I plug in 2 for x, I'm going to get, well, 3 times 2 is 6, minus 2 is 4 for y. So that works. If I plug 2 in for x in equation 2, I'll get minus 10, because it's minus 5 times 2. And minus 10 plus 14 is, again, 4 for y. So it works. And then the very last thing I want to say here is that if we were to go ahead and graph each one of these lines. So y equals 3x minus 2 is here in red, and y equals minus 5x plus 14 is in blue. And what we see here is that the two lines cross at this solution point we just found, right? With this point with coordinates 2, 4. Because for a point to lie on one of these lines, it means that if you plug in the coordinates, it'll make the equation true. And we're looking for this special point that'll make both equations true. So we're looking for the point of intersection of the two lines. All right, well, that's going to do it for this problem. I'll see you in problem 2 next.